All right, let's talk about objects that should not exist. Not rare, not unusual, explicitly forbidden by the physics we use to explain everything else. These are 10 things the universe built while ignoring its own rulebook. Number 10. TOI 5256b. The Forbidden Planet. Planet formation has a strict playbook. A young star forms surrounded by a spinning disk of gas and dust. Over millions of years, particles collide and stick together, growing into rocky cores. Once a core reaches about 10 Earth masses, its gravity becomes strong enough to vacuum up vast amounts of hydrogen and helium, inflating into a gas giant. Jupiter is the textbook result of this process. But the whole thing requires enormous raw material. The disk must be massive, and the star must be large enough to sustain it. TOI 5256b orbits a red dwarf 280 light-years away. This host star has only 39% of our Sun's mass. A star that's small produces such a thin, sparse protoplanetary disk that our best models say it physically cannot generate enough material to build a gas giant. The disk would evaporate before anything significant grew. Yet TOI 5256b is a gas giant roughly the size of Jupiter. When it passes in front of its star, it blocks 7% of the starlight. Most planetary transits dim a star by a fraction of a percent. This one is like hitting a dimmer switch. Astronomers call it the Forbidden Planet. Finding a gas giant here is like finding a sequoia growing out of a crack in a sidewalk. The raw material was never there. The physics explicitly forbids it. TOI 5256b forces us to admit that our model of planetary formation is missing something fundamental. Number 9. Przybylski's star, the radioactive anomaly. Stars are predictable chemical factories. Fuse hydrogen into helium. As they age, produce heavier elements, up to iron. When you analyze a star's spectrum, you expect familiar elements in familiar ratios. In 1961, astronomer Antoni Przybylski pointed his telescope at a star in Centaurus and found a spectrum that broke every rule. Przybylski's star is missing expected elements like iron. Instead, its atmosphere is loaded with extremely heavy radioactive actinides, promethium, actinium, curium, and, most disturbingly, einsteinium. Einsteinium does not occur in nature. It is a synthetic element only producible inside particle accelerators. More critically, Einsteinium-253 has a half-life of 20 days. 20 days. In astronomical terms, that is essentially zero. For this element to remain continuously visible in the spectrum, something must be creating it constantly, right now, using a process we have never observed. Standard nuclear physics says these isotopes should have decayed into stable elements billions of years ago. The mainstream explanation suggests the star is evidence of the theoretical island of stability, a predicted region of super-heavy elements stable enough to persist. We have never proven this island exists. The fringe hypothesis is more uncomfortable. The star's chemistry is artificial. An advanced civilization either dumping nuclear waste into their star or deliberately seeding it with synthetic isotopes to create an unmistakable beacon for anyone who can read a spectrum. Number 8. The Big Ring. The cosmological principle breaker. Modern cosmology rests on a single foundational assumption called the cosmological principle. On large enough scales, matter is distributed roughly evenly throughout the universe. This is not just a preference. The equations of the Big Bang only function if it is true. The expansion of the universe gives us a hard structural size limit. Gravity has only had 13.8 billion years to pull matter together. Based on this, physicists calculated that no structure in the universe should exceed 1.2 billion light-years across. Anything bigger would require more time than the universe has existed to form. In early 2024, astronomers announced the Big Ring, a perfectly circular formation of galaxies 9.2 billion light-years away. Its diameter is 1.3 billion light-years, already larger than the theoretical maximum. Its circumference covers roughly 4 billion light-years. If you could see it in the night sky, it would span 15 times the width of the full moon. The Big Ring sits directly adjacent to another impossibly large structure called the Giant Arc, spanning 3.3 billion light-years. Two structures that each individually break the rules side by side. There is no known mechanism that builds a perfect ring of galaxies at this scale in the time available. If the Big Ring is confirmed, our standard model of cosmic structure is wrong in ways we have not begun to calculate. Number 7. PSRJ 1748-2446 AD. The centrifugal nightmare. When a massive star dies, its core collapses into a neutron star, a city-sized object containing twice the mass of our Sun. Conservation of angular momentum sets these objects spinning, and some spin fast enough to become pulsars, sending out regular pulses of radiation as they rotate. PSRJ 1748-2446 AD, located 18,000 light-years away, holds the record as the fastest spinning pulsar ever discovered. It rotates 716 times per second. Its equator moves at roughly 70,000 kilometers per second. That is 24% the speed of light. At that velocity, the centrifugal force at the surface should overwhelm the inward pull of gravity by a vast margin. The star should tear itself apart and detonate. The reason it does not comes down to the most extreme state of matter in the known universe. Under the crushing pressure inside a neutron star spinning this fast, atomic nuclei deform and merge into configurations physicists call nuclear pasta. Matter stretches into spaghetti-like tubes and compresses into flat, lasagna-like sheets. This degenerate nuclear matter is estimated to be 10 billion times stronger than steel. It is theorized to be the strongest material that can physically exist, and it is the only thing holding this star together. If the spin increased even slightly, the nuclear pasta would fail. The star would detonate. PSRJ 1748-2446 AD is the universe's most extreme stress test, and it is passing by the narrowest possible margin. Number 6. Thorne-Zitkov objects, the star within a star. Stars are supposed to be solitary fusion engines. In 1975, Kip Thorne and Anna Zitkov described the physics of something that should not be possible, a star living inside another star. The scenario begins in a binary system containing a red giant and a neutron star. As the red giant expands with age, it swallows the neutron star. Instead of immediate destruction, atmospheric drag causes the neutron star to spiral slowly inward over thousands of years, sinking until it reaches the red giant's core. The result is a Thorne-Zitkov object, two completely separate engines of physics running simultaneously inside a single star. The outer shell continues normal hydrogen fusion, completely unaware of what lies at its center. The neutron star core tears apart infalling material through gravitational accretion, generating heat at temperatures fusion alone could never produce, and creating heavy elements in quantities no standard stellar model can explain. This was only a theoretical prediction until 2014, when astronomers detected a red giant called HV 2112 in the Small Magellanic Cloud with spectral signatures wildly wrong for any standard stellar type. Elevated rubidium, lithium, and molybdenum. Exactly the heavy element exhaust predicted for a dual-engine Thorne-Zitkov object, a neutron star burning silently inside another living star. Number 5. SDSSJ 0100+2802. The timeline breaker. Black holes have a speed limit when feeding. As matter spirals in, friction generates intense radiation. Feed too fast, and the outward pressure of that radiation pushes back against the infalling material and chokes off the supply. This ceiling is called the Eddington limit. It is one of the most reliable constraints in astrophysics. SDSSJ 0100+2802 is a quasar 12.8 billion light-years away, seen when the universe was only 900 million years old. At its center sits a black hole containing the mass of 12 billion suns. The math does not work. Even starting from the most massive possible stellar remnant of the first generation of stars, feeding continuously at the absolute Eddington limit every single day from the beginning of the universe. A black hole cannot reach 12 billion solar masses in 900 million years. The Eddington limit physically prevents it. Either early black holes bypassed radiation pressure through a mechanism we have not discovered, or they merged in ways our models cannot produce, or the universe is older than we think. All three options unsettle the foundation of modern cosmology. This object sits in the deep past, quietly announcing that something about the early universe is fundamentally broken. Number 4. WASP-107b. The Cotton Candy Planet. Gas giants need a heavy anchor. Standard models require a rocky core of at least 10 Earth masses before a planet can gravitationally hold an envelope of hydrogen and helium. Without enough core mass, the gas drifts away. This rule is foundational. WASP-107b is roughly the same size as Jupiter, but 10 times lighter. Its density is comparable to a toasted marshmallow. When astronomers calculated the mass of its core, they found approximately 4 Earth masses, less than half the theoretical minimum required to bind the gas it has already accumulated. It gets worse. WASP-107b orbits its star every 6 days. At that distance, intense stellar radiation should strip the planet's weakly held atmosphere through a process called photoevaporation. The gas envelope should have been vaporized billions of years ago. The planet should now be a bare, rocky core. The atmosphere is still there, bloated and light, orbiting dangerously close to a star that should have stripped it bare, held together by a core nowhere near massive enough by the rules we thought were absolute. WASP-107b should not have formed and should not have survived. It is doing both, and it will not tell us how. Number 3. Higgs Object. The Galaxy Without a Past. Every galaxy carries the scars of its formation. Spirals are shaped by angular momentum. Ellipticals bear marks of ancient mergers. Ring galaxies form when a smaller galaxy punches through a larger disk galaxy, and the shockwave ripples outward into a ring of new star formation. Higgs Object, discovered in 1950, carries no scars at all. At its center is a perfectly round core of old yellow stars. Surrounding it is a gap of completely empty dark space, tens of thousands of light years wide. Surrounding that gap is a perfect ring of young blue stars. No spiral arms, no connecting structure, no debris trails. A disconnected bullseye floating in the void. No standard model of galactic evolution produces this without a collision. But Higgs Object shows zero evidence of any collision. No companion galaxy, no gravitational distortion, no scattered remnant material. Whatever created this geometry left no trace of how it did so. And through the gap between the yellow core and the blue ring, there is another galaxy directly behind it in the background, with the same impossible ring structure, the same disconnected bullseye. The odds of coincidence are uncomfortable. The alternative requires a physics we have not discovered. Number 2. The Pulsar Planets, born from death. The first confirmed exoplanets were found not around a warm, stable star, but around a pulsar. PSRB 1257 plus 12 is the spinning, dense corpse of a massive star destroyed in a supernova. Around it orbit 3 rocky planets named Poltergeist, Phobetor, and Draugr. If these planets existed before the supernova, they should not have survived. The explosion releases enough energy to vaporize any rocky body at close range, strip every atmosphere, and scatter remaining debris at a fraction of light speed. If they formed after the supernova, the problem is equally severe. Planet formation requires cold, stable material settling slowly under gravity. A supernova blasts everything outward at extreme velocity. For a disk to form from this debris, material would have to decelerate, reverse course against the outward pressure, and settle into a stable orbit around the dead star. Then planets would have to grow in a highly radioactive environment, bathed in lethal pulsar radiation. They exist, confirmed by multiple independent observations. Every mechanism we know either destroys them before they form or makes their survival impossible afterward. Zombie planets orbiting a dead star in permanent defiance of the physics that governs everything else we know. Number 1. Type 1 AX. Supernovae, the stars that refuse to die. White dwarfs are the cooling remnants of stars like our Sun. If one exists in a binary system, it can pull gas from its companion. As mass accumulates, it approaches the Chandrasekhar limit at 1.4 solar masses. Past this point, the white dwarf can no longer support itself. It collapses. A runaway thermonuclear explosion ignites. everything burns. The star is completely obliterated. Nothing is left behind. This is a Type 1a supernova. The physics is absolute and consistent. We use these explosions as standard candles to measure cosmic distances precisely because every single one produces the same complete destruction. Recently, astronomers confirmed a variant called the Type 1ax supernova. The white dwarf reaches critical mass, triggers the explosion, and something in the detonation fails. The fusion stalls. The blast is asymmetric. The star does not fully burn. When the light clears, the star is still there, scarred. Transformed, still radiating. A portion of the white dwarf has survived its own total destruction. The asymmetric blast acts like a rocket engine, launching the surviving remnant through the galaxy at millions of miles per hour. We do not understand why the detonation fails in some white dwarfs and not others. We do not know what fraction survives or what determines the outcome. What we do know is that dozens of these zombie stars have been identified, burning through the dark, demanding an explanation we have not yet found. Subscribe and keep watching.